Given two strings, S1 and S2, both lowercase. Find the shortest contiguous substring of S1 such that S2 appears as a subsequence inside that substring. If no substring works, return empty. If several windows tie for shortest length, return the one that starts leftmost. Example, S1 is A B C D E B D D E and S2 is B D E. The substring B C D E has length 4 and contains B, then D, then E in order. Another length 4 window is B D D E, but it starts later, so the answer is B C D E. The pattern is a subsequence of the source. Its letters must appear in order but they do not have to be adjacent. Many contiguous windows of the source can work. We want the shortest, and if two tie we take the leftmost start. Index I marks where you are reading in the source string S, index J counts how many characters of the pattern T are already matched in order. The yellow pointer tracks I above S, and the green pointer tracks J below T. Now the step-by-step walk on the sample. At I0, S shows A while T still wants B, so J stays 0. At I1 both sides show B so J advances to 1. At I2 S is C but T still wants D at J1, so J waits. At I3 both show D so J becomes 2. At I4 both show E so J becomes 3, so all of T is matched inside the prefix 0 through 4. That proves a valid window ends at index 4, but we have not yet found the smallest left edge for that end. Keep the end fixed at 4. The whole prefix up to there already matches the pattern, but the first slot is wasted. The first B you actually need is at index 1. Now walk backward along the dashed links, work from the end of the pattern inward, and each time grab the rightmost match still inside this stretch. That trims the left edge to 1, so the tight window is indices 1 through 4. Record that window. Slide the anchor to start +1, index 2 on the C, and run the same forward rule again. You hit B at 5, D at 6, E at 8, so another minimal window is 5 through 8 with length 4, same length as before, so the tiebreak will matter next. Among the minimal windows you discover this way, take the smallest length. If two tie, pick the one that starts earliest. Here both length 4 windows tie, so the leftmost wins, B C D E. Full solution walkthrough on a fresh sample, source A B C C D B C D and pattern BD, so you see more than one forward and backward pass. We track red index I in the source, match index J in the pattern, and the best window so far. The status panel lists only the variables that matter for the current phase. Phase 1, forward scan, anchor 0. I moves right, J only advances on a match. Index 0 is an A, no match. Index 1 is A B, J becomes 1. Indices 2 and 3 are C, J waits. Index 4 is A D, J becomes 2, which equals the pattern length, so the forward phase ends. The end of this candidate window is index 4. Phase 2, backward shrink. We freeze the end at 4 and walk I back, this time matching the pattern from its last character inward. At index 4 the D closes J to 0. The C at 3 and the C at 2 skip. The B at 1 closes J to -1, so the tightest start for end 4 is 1. We record the first candidate, best start 1, best length 4. Restart the anchor at start +1, index 2, then run the same forward and backward passes again. Forward, C C D miss, then B at 5 flips J to 1, then D at 7 completes the pattern, so end is 7. Backward shrinks the start to 5. The new candidate has length 3, which beats 4, so the best is now start 5, length 3. Restart once more at index 6. Forward sees only C then D, never finds AB before the source ends, so this pass aborts. No new candidate, and the loop exits. The recorded best is start 5, length 3, so the answer is the substring BCD. Let n be the length of S1 and m the length of S2. Worst case time is O of n times m. Each restart can scan a long stretch of S1 while matching up to m pattern letters, and there can be on the order of n restarts. Auxiliary space is constant, only a few indices and the running best window length, not counting the return substring. Function min window subsequence. Shortest contiguous substring of S1 that contains S2 in order. Let n be the length of S1 and m the length of S2, constraints guarantee m is at least 1. Track the best window start, its length, and the scan index I in S1. Outer loop, keep trying new windows while I stays inside S1. Reset pattern index J to 0 for a fresh forward match. Inner forward loop, walk I along S1 until we match all of S2 or run out of S1. If the current characters match, we can advance the pattern. Consume one matched character of S2. If J reached M, we have matched the full pattern, exit this inner loop. Otherwise move I forward in S1. If I reached N without a full match, stop the outer loop. Record end as the index in S1 where the full pattern finished. Set J to M-1 so backward matching starts at the last pattern character. Inner backward loop, tighten the left bound while J is non-negative. Walk backward, align pattern letters from the end while moving I left in S1. When S1 at I matches S2 at J, consume another pattern letter backward. Always step I left to search for earlier matches. Tight start is one step to the right of where backward walk stopped. If this window is shorter than the best so far, update best start and length. Restart the outer scan from the next anchor, start +1. If no valid window was ever found, return empty string. Otherwise return the substring of S1 from best start with length best len.